So this is where, like, I'm kind of squeezing notes in there. This is where I'm wondering, like, do you prefer that I gave you this packet and, like, we kind of wrote notes in, or would you rather just, I talk and you write your own notebook? It doesn't matter. Okay. Alright, let's go back to previous page. Let's look at Rumpel's situation here. Does the limit as x approaches 1 exist for this one? Yes, it does, because those rows come together. So whatever this y value is here would be the limit. Does f1 exist? Or same question, is f defined? Or same question, is there a bridge? Yes, there is. So far so good, but the problem is they're not the same spot, right? The bridge is up here, the rows come together down there, so the limit does not equal the value. And again, the only way it's continuous is if all three of these are yes. So it's not continuous. And then you got to know what kind. So is it a jump, a removable, or a vertical asymptote? That is a removable. And we'll eventually get into, like, how would you remove it? We kind of talked about some with the piece, but not all the way. Alright, Quinn's is just brutal here. Does the limit exist? Nope. Is the function defined? Like, is there a bridge? Nope. So, the limit k equals the value because either one of them even existed in the first place. So, is it continuous? Nope. And what kind of discontinuity? So you could say infinite or you could say vertical asymptote either way. Like, I hardly ever think of infinite discontinuity. I'm just like, oh, that's a vertical asymptote. And that's fine on the AP test too. So you can use them interchangeably. So this is a vertical asymptote. And I guess technically if he's wandering along the river, he's got to be getting like a little closer every time, you know. It's like trying to play a game of chicken with the river and trying to see how close he is. Alright, Caitlin's. Does the limit exist? No, why not? Rows don't meet, or like the limit is different from each side, right? Those are the same thing. Does f1 exist? Yeah, she built a bridge on one of the roads. The limit can't equal f of 1 because the limit didn't exist. So therefore, it's not continuous. So it's obviously not a vertical asymptote. Is that a jump or a removable? That's a jump. You're going along one road, you got to jump to get to the next road. Questions on that front page anywhere? Try Madsen rows on your own. If you just want to like think through in your head, not right now because you don't want to write the wrong thing, but totally fine. But just think through those couple and I'll go through them and we'll see how we do. Interpret the pencil draw. Was it like, I have no idea what I'm doing, or this was easy? That was a drop. That was like a little more violent. So it was not. I don't know. Right. Sorry. Alright. In math, does the limit exist? Yep. Does f1 exist? No, so these can't equal. It's not continuous. What kind of discontinuity? Removable. Emily's. Does the limit exist? No. There's no bridge. This is just as bad as Quinn's, actually. There's no bridge. So they can't exist. It's not continuous. And what kind is that? That's a jump. And then, so here's where everything lines up. Does the limit exist? Yes, because the rows come together. Does F1 exist? Yes. There's a bridge there. Are they the same? Yes. Is it continuous? Questions on this anywhere? Okay. On the next page. Same idea, we're just looking at like a bigger picture here. And this is another reason I gave you the packet. Because if I draw this, I'm like, everybody copy this down. It's just like a waste of 5 minutes, and it's hard to copy it down. So I was trying to speed things along. So list all discontinuities, and what I mean by that is list all the x values and tell what type. So I'll do like the first couple, and then I'm going to have you finish the rest of that. So I'm just going to go left to right. Like everything's fine. I'm getting across all the rivers. And then x equals -3. I do have a discontinuity because if there was a river at -3, I wouldn't get across it. What kind of discontinuity is that? So you can say infinite, or you can say vertical asymptote. I'm just going to kind of keep reading left to right. So everything's cool, I'm smooth, I'm fine. And then when I get to x equals -2, I've got another issue there. If there was a river at -2, I wouldn't get across it. So x equals -2. What kind of discontinuity is that? That is a jump. Yeah, see what I'm doing? Go ahead and do the rest. Don't worry about the second part yet. Just do that first, the first one. Got those? Same as I have? Questions there? Okay, where is the function continuous? So the thing that gets tricky here is like the parentheses and the bracket. So remember, a bracket means you're including the endpoint, where a parenthesis means you're not including. And you can have like one of each, so that's what we're going to have a lot of going on here. I'm actually going to write the answer like up here, just because I can zoom better and show you more at once. Kind of line things up better. So you're looking at kind of each place it's not continuous, if you're basically building around that. So I know there's issues here, 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 and there. So kind of everything in between is where it is continuous. You got to be careful about the brackets, the parentheses. So negative infinity can never have a bracket. You can never include the lowest number, because whenever you tell me the lowest number is, I can tell you a lower one. And you can be like, all right, Jack, it has to be that way. I'll tell you a lower one. We can just like keep going forever. So you're going to say negative infinity up to -3, and I'm not ever touching -3, right? So that gets a parenthesis also. Question? This piece, am I going to include the -3? All right, put the parentheses, I guess not. Am I going to include the -2? I'm not, so I guess I should do do that too. So the closed dot means you're including, and the open dot means you're not. Which I think you guys already know this. I'm just confirming. But then for this piece, this part here, I do have a closed dot on that side. So now I'm going to go, okay, that's from -2 with a closed bracket up to -1 with an open. So it's a little goofy because the -2 is open on one side and closed on the other. That's just because there's an open dot on one side and closed dot on the other. So the next piece would be from -1 to 0. Those would both be parentheses because it's open dots both times. Next piece would be from 0 to 1, and the 1 would have a closed bracket because that's a closed dot. 1 to 2, those would both be open because we got an open circle and then an asymptote, which we never technically get to that number, right? 2 to 3, it's not continuous there. Even though there's a closed dot there, it's this open circle that matters more. And then 3 to infinity, and again, you can't put a bracket on infinity because whatever you tell me the biggest number is, I can do a higher one, you can be higher than that, you can just keep going with it. So if you're asked to tell me where it is continuous, this is what you're looking at, like list, you guys see what I'm saying, list the pieces in between, kind of. Questions there? Do the one on the back. Thank you. Go ahead and check your answer with mine. Check mine, I might have made a mistake too. See the match. So be careful about checking like the brackets and the parentheses because it does matter. If you're done with that, the rest of the time gets your homework, or your classwork, homework, whatever. So the rest of it's practice. You're good here, just turn the page, and it's like a worksheet, and then answers, and then another small worksheet, and then answers. All just practicing this stuff, so you're working on that. So did you go like 1 to, or 2, you can go 2 to 3 and 3 to 4. I mean, because really, it's not going from 1 to 2. Any questions on that one on the board? Yeah. That's not a question on the one on the board. Yeah, they're supposed to be very much. So then, look, tomorrow we'll do. How would you do that algebra? So they can actually. I can talk about it. Zero. I'll get a zero on the bottom. And we'll put a zero on the top. That's the really? It's awesome. It's weird. So then you know what it is if it's zero on the top and the bottom? No, we don't do slight F's. There are slight S's, but they're not this fun. 0 to 0 is
Oh, right.
Yeah.
On that one, I had to go out for the whole, and I was like, I have to work, and I just put it on the ground.
For what? Pre-contest?
I'm sorry.
For any pre-contest?
Yeah, it was like, we had like a whole, with, answers plug in, and then you have the ground base well.
Right.
And I did all the work.
And then put like the
And I
transfer
did
it.
it on that thing, so.
You're still talking about it.
Yeah, I know.
6 months later.
I'm so sad.
I was like, yeah, she hasn't shut up much. Yeah. Open is the parentheses. Yeah.
Okay.
Good. Yeah, so this is like technicality. So technically the limit is supposed to be that's infinity, and that's like not a number. So that's why. But don't worry about it. There's no gaps, so you're just listing like the whole. You're gonna just list all the X values, which is do 2 circles.
Or just like turn my paper on the side where it